Hey everyone, Michael Bowman here from Vertical Works. Today is June 15th, 2015. Today's lesson is a real-world example on normalization for databases. We're going to normalize a few tables for pet, an owner, and ownership. Now, some people think that an owner just owns a pet. That could be true. But in the real normalization sense, you could have two owners, and each one has 50-50 ownership, or 75-25, or any combination thereof, as long as it adds up to 100%. So how would you normalize that? Well, I'm going to show you how to do it. Let's jump over to my whiteboard, shall we, and get started. Let's go over this, shall we? I got a special request from someone trying to model, hello dog, down you go. Someone trying to model owner, pet, and ownership. And I guess basically what they did is they went from here to here. So I'm just going to show you how to normalize it, right? We'll use this as a real world example. All right, so we have an owner table, we have a pet table, we have an ownership table. And keep in mind metadata. Remember to add the metadata. Create date, last modified by, timestamp to every single table you do, period. Okay? The hallmark of a professional system. Now, let's go ahead and work this out. I've put this out here. I'll walk you through it. Now, the person that sent me the email went like this. And that obviously didn't work. That fell apart really quick. Okay? Owner has one or more pets. That's true. An owner does have one or more pets. The problem is, though, they didn't count on multiple owners having ownership of the same pet. So it crashed. It wouldn't work, you know. They started having duplicate data. It just got messed up. So here's how you normalize it out. Let's walk through it. Every table has a primary key. This has a foreign key. For this, I'll explain that later. Name, age, and phone. Keep in mind, phone really should be off in another contact table because one owner may have multiple phone numbers, multiple emails, multiple addresses, right? So normalize it. But for now, I'm just, I probably should just get rid of it. There, we'll just go with that. Name and age, right? Those are dependent on the key, the whole key, and nothing but the key. Now, take a look at that. Ownership, primary key, foreign key back to here, foreign key back to there, and percent owned, okay? So there's a constraint on percent owned, right? You can do it with triggers. You can do it with before triggers. SQL Server gives you before and after triggers for insert and update, right? And delete. Oracle as well, okay? Two great engines. We'll talk about terms in a minute. Anyway, we have 3 rows of data here. We have 3 rows of data here. That means we have 3 owners, we have 3 pets, and then we have to worry about our ownership. Let's take a look. In row number 1, in this table, that's what this data set is. Owner number 1 has ownership of pet number 1 at 100%. Next row, owner number 1 has ownership of pet number 2 at 50%. Next row, owner number 2 has 50% ownership of pet number 2. That totals 100%. So you can't add any more rows in here for pet number 2 because that will violate this constraint, which says a pet can only be owned 100%. However you want to chop it up, that's great, but it's 100% max, right? Owner number 3 owns pet number 3 at 100%. Okay? The constraint would be then enforced. So I hope that makes sense. That's how the data would play out for your scenario. Okay? And I put terms up here because you mentioned it, but you didn't model it. But I'm going to do it for you. Parent table, child table, many to many, intersection table. But this table can also be a parent in its own right because one ownership record may have one or more terms associated with it, according to what you told me, right? That terms did not exist up here, right? There could actually be another set of terms, right? For something different, but for the ownership itself, you said there were terms. So ownership, one to many on terms. That way you lay it out correctly. Okay, I hope that does it for you. That's a pretty simple third normal form. Oh, one thing I did forget. Let me go ahead and share that with you. Got a foreign key here. It's nullable. This is a pigs relationship to itself. It's a one to many to itself. What does that mean? Well, essentially that a pet can be the parent of another pet or more than one pet. So every parent or every pet basically has a parent or can have a parent. but doesn't have to. I mean, at some point it can stop, right? The very top level parent may not have anything, right? There's got to be a point where it stops the top. So this is really good. You can set up a pet and then have children. That's what that's for. Okay, people call it a pig's ear. Referential integrity, back to itself. DRI. Okay. Well, I've told you in many videos, it's important to use the functions of the engine correctly, because if you don't, you are basically, it's like overriding a function. Now you have to supply everything. You can inherit, in object-oriented modeling, you can inherit, there's an ISA relationship, right? So in an ISA relationship, you can inherit from the parent. You are that. And then you can override, and now you're writing custom code. So you can either use what the parent has or overwrite. If you walk away from what the engine gives you, you're going to have to do it all yourself. And I submit to you that that's crazy. Why reinvent the wheel? Now, declarative referential integrity, basically, in the engine, you can declare these relationships, and you can set up, cascading deletes, you know what I'm saying? You can adjust the properties so they behave differently. Sometimes it's kind of scary to think that you have a cascading delete that can go and just wipe everything out, but so you might not want to use them, but it's there if you need it. So use what the engine has. Remember too that there's indexes, right? Use those accordingly, but get your stuff into third normal form. Get it down to the key, the whole key, and nothing but the key. If you were to shove all this stuff up into one table, the engine would be like, well, it would update things incorrectly probably. So you'd have to be looking at all the different combinations of columns and whatnot to get the updates right. And it's a lot of work. If you do it this way, the engine can handle all that. And then you just, you go and you target a table and do your insert updates, boom, boom, boom. But the engine will do all the heavy lifting is what I'm saying. All right, well, that's it. I just wanted to make it quick, down, and dirty. That is your little model, so I hope that helps you. And if you have any questions, give me an email. This is Michael at verticalworks.com, and I'll get out of the way so you can take a look at it. Have a great day.